Alright, so we'll get started on debuggers now. One thing, make sure you go to attendance on the website, just so that we know you're here. Helps with attendance and stuff, obviously. It's dsuprog.club/meetings. Um, but with that, we'll get started on debuggers. So what are debuggers? I mean, it sounds kind of obvious, but they're used to help you debug a program. Today we're focusing on C and C++ debuggers because that's a language we use fairly frequently here at DSU, so it makes the most sense. It can help you do logic errors without doing like printfs everywhere to know where things like what's happening, so you can just run it through your debugging and then you'll be able to help figure out what's happening without also then having to go back and like comment out and delete prints and stuff, because that's the most useful debugging. And then it's really helpful to locate causes of seg faults, because it will give you exactly where the program seg faults, so you can kind of examine what the state of your program is right there and then figure it out from there. So we'll be talking about GDB and lldb. GDB is the debugger for GNU. It's installed by default in Linux, and if you install MinGW or there's like one other compiler onto Windows, you can use it on Windows as well. And then there's also lldb, which is used with Clang. That's for Mac. That's what I'll be using tonight when I demonstrate. But they're like basically the same thing. The commands are more or less the same. There's a few differences, but when I hit those differences, I'll kind of point them out. So from there, you use it. So you have to compile your program specially with TACG like this. When you do this, it builds your program and then adds the special debug things in it so that your debugger knows like what's happening in the file. And then if you and then you go in, enter it like this, you'll just do GDB, the name of your executable, and then it launches GDB, and then you can start entering the debugging area where you can start getting ready and then debug your program. So there's a bunch of commands. I put a link in our resources page to a PDF with like a bunch of commands, like so many commands. I'm not going to go over all of those. I'll go over the important ones. This is probably the most important one, break or B. All of them, if there's a slash there with just one letter, you can use just the letter to do the command instead of the whole word. But it places a breakpoint at the designated line. And what a breakpoint is a way for you to tell your program where you want to stop execution in the debugger. So if you do like, so it helps you know where to stop your program in an area where you know that it probably is breaking here, so you can like run through all the parts that work and then it'll stop at the broken spot, and then you can control execution line by line from there. Delete will delete breakpoints. Pretty self-explanatory. So continue will do that. It runs your program until it hits the next breakpoint. Because if you use next, it goes line by line. Stepping over functions here means if you hit a function call, when you hit next, it will just go right to the next line after the function call. The function will run all by itself separately. If you step when you hit a function call and then you step again, it goes into the function, and you can run your program execution follow through in the function if you so desire. And then printing, very powerful. You can print a variable, so this way you'll know what variable values are to make sure that everything is getting set properly. You can read them from there. You can print indexes and arrays too. To print an entire array, you'd have to do a little bit something else, which I'll cover here in a sec. But printing is also a very useful thing. Info lists all of your breakpoints. It gives you where they are and the number that they are, that like GDB is identifying that breakpoint by. Call is the thing I was getting to now. You can call a function separately. So an example would be if you have a function that loops through and prints your entire array, you could then call print array on that array, and then it will run through and it'll output the printing of the entire array. You can also use this to evaluate expressions. So like you can call I equal 10, and then it'll print true or false to see if I is equal to 10 or not. Stuff like that. T-break, temporary breakpoints. These are good to stop so you know where the program is, but then if it goes back to it, it won't be there anymore. So like if in a for loop you wanted to make sure you get into the for loop, you could put a temporary breakpoint in the line. It'll hit it on the first iteration, and then from then on it'll just iterate through the loop like normal. Conditional breakpoints are really useful if you want to only examine what your program is doing, like if a variable is like less than 5 or something. So some programs, you have lots of branching with if statements and stuff, so sometimes you want to examine a certain case, so you want to have to only debug when it hits that case that isn't working, when a different case might be working just fine. And then run will run the program. Finish just goes straight through. It will ignore the rest of your breakpoints and go to the end of the program. Exit is the command for lldb. I learned this like 10 minutes ago. Not 10 minutes ago, but like an hour ago, that quit is how you'll do this in GDB on Linux. And then help would display, all the help information. So this is just a quick example of how you would use all of these commands. And again, we'll run through an example here in a little bit, kind of explaining how to use these commands. But as you'll see, that's how you would set a breakpoint at line 17 right there at the top. I didn't mention this, but you can set a breakpoint at the start of a function like I'm doing there. Then the fifth line where it's run and then 12 and file.txt, that would be running that file with command line arguments. So obviously it wouldn't always be 12 like a number in a file. Whatever, if your program needs file or command line arguments, you would put them there like that. There's how you would set a conditional breakpoint right below the info, and there's printing, and so that's basic usage of all of them. Again, in resources, there's a link to a bunch of GDB commands. So you can debug in Visual Studio Code. It's very similar to GDB and lldb because it's basically built off of those. By default, it uses those unless you installed like a separate debugging package. And the nice thing about this is it provides, like a graphical setup, so you can like see it and click buttons and stuff like that, unlike GDB, which would be command line based. One problem, it is not like super fine-tuned, I've learned in C++ and C. For example, if you have any scanfs in your program, I couldn't get it to work on my Mac. It might work. You might not be able to use that. But if you're debugging with C and C++, you'll have MinGW or something installed, so then you can just use GDB if you have to. So any questions right now before we jump into the demo? I'll take that as a no. So here I whipped up just a simple little program, very not useful in the real world, but makes an array. It'll loop through the array and assign everything in it a random value, and then it prints the array after that. So if we do a quick compile here, and then run it, you'll see it segfaults. Now in a program like this, it's 17 lines, you'd probably be able to just look at it, figure it out. But in really large files, it is much more difficult. So that's where debuggers come in handy. So what we'll do this time is compile it again, but this time we'll add our TACG flag there. That'll compile it like normal. And then again, I'm using lldb. GDB is what you would use on a Linux system or Windows. So there it's set my target executable to a.out. So now I can get ready to debug this program. I'm going to set a breakpoint in our first for loop there, and then in the second one as well. and then one actually in that second one. So there I've set some breakpoints so that once I start running this file, it'll stop. So then we'll run the file. It'll do stuff. This is just a Mac thing. And then look at that. It stops right here at line 11. So from here, I could print stuff or like here, I don't know if I is defined here. So I is 0 right now because it's defined right there in that for loop. So you could print like that. Obviously right now the program still works. So we'll continue on. I'm just going to move on to the next breakpoint. So now we've hit this one here at 14. We'll see everything has run just fine. We've assigned our array some random values. Now we'll move in, because there's not much left in the body of this program. We know it has to break somewhere in this for loop. So I will move to the next line. We'll see it still works. I can print I again. It'll be 0 again. I can print some array values if I really wanted to. So at index 1, our array has the value of 61. So then we'll move on to the next line, and we'll see here it hits a seg fault, as you can see by x bad access right there. So this is where we can see our program is broken. I'm not entirely sure actually why it seg faults here where it is. We've looked at it. It should have probably seg faulted somewhere in the top for loop. But if you look at this, big problem is our size is 400 while our array is only 200 elements. So it obviously you can't read index 300 from an array that doesn't have 300 elements. And this is an example. It could happen, you could set it at 200 because maybe that's what a professor told you to do. And then later on you wanted to add a size variable, you forgot the number, you put a different one there, and it could just break everything. So that's how you would use GDB. Oh, I didn't want to do that there, my bad. Then if we wanted to debug this with VS Code, it'd be fairly similar. Click this debug button over here. To debug in VS Code, you have to have a folder opened, not just a file, because then within that folder or directory, it creates like a settings file for your debugging. I've already done that, but you'll see a button that says run and debug. You'll click it. You'll click C++ when it brings up the menu, and then it'll create the file for you. So we'll add a breakpoint right next to the line numbers here. We're just going to put one here this time. And then we would click run. This is hopefully working. So here in this debug console is where we will be able to add expressions and stuff. I think I actually messed this up. Oh, this is me trying to debug it earlier. Okay, let's try this again. Okay, but in this debug console, this is where you would normally be able to, there we go. This is where you can add all of your regular commands. So if I wanted to print whatever I was, I would add this tag exec flag, and then I could pi. And then it tells me that I is 0 right now. And you'll see here it stops on this breakpoint. So then our buttons here, this would be equivalent to next. This would be equivalent to step. And then this one would step out of a function if you're in a function and bring you back into your main program or whatever called the function. And then this would be continue. So we'll see here if I click next, it breaks again. It tells us that there's been a bad access right there. And then you can go on and debug your program from there. So debuggers are obviously super useful because it can cut down a lot of time on debugging, especially bigger programs with lots of function calls where you don't want to have to go add print statements everywhere. You can just run through the program. It'll tell you where it breaks. You can access any variable you want as long as you haven't hit an area like this. Like right now, I can't access I because we segfaulted. But use them. If you're in any of Tom's classes or any other professor where you log onto a Linux server, you would have, I would assume, access to GDB to work on your files like that. If you're developing locally, then you probably have like MinGW or something installed, so you would again have access to GDB. Or if you use Visual Studio Code, you'll have the built-in ones. But relatively shorter tonight on the standpoint of debuggers. Side note, I put the link to the Sanford Health Hack registration in the resources page as well. So if you need access to that, you can go there. Again, make sure you go and do attendance. Just click on meetings and then join meeting. Question here. Is the debugger in VS Code compiling the code via the Mac terminal? No, it is not. It compiled it itself. That was the part, if you remember, it took a bit for VS Code to do it. That terminal window that showed up was just when I was trying to get scanfs to work, because I had seen on Stack Overflow that can help, but it didn't work properly. But it will do it all by itself in VS Code. At least it should. So yeah, that wasn't a Mac terminal thing. Any other questions? All right. Well, I guess with that, next week, I believe we are doing Docker. We're going to have Brendan from last year. He was one of the officers. He is going to present on Docker. So that will be, it's a very useful tool when you're doing some cross-platform development stuff. So definitely tune in for that. Also, you would have all gotten an email, but there's that State Farm coding contest this Saturday. I would encourage you to sign up for that and do it. Coding challenges like that can be super useful to improve your skills and just practice programming. And then also do the Sanford Health Hack. That can be also a really good experience for you. And if you win, prize money doesn't hurt either. So. But I guess with that, again, assuming there's no more questions, we'll end tonight's meeting. So go have a nice night and do homework if you have to.